This video lecture is meant to cover the material from Chapter 10, Chemical Quantities, and Section 1, which is all about the mole in chemistry. To start off our discussion, we have to discuss counting by weighing. When you're dealing with very large numbers of an item, often many orders of magnitude above anything you would consider counting by hand, you can count your items by dividing the total mass of the sample by the mass of an individual piece of the sample. The United States Mint counts money by weighing, using well-established averages to quickly count by weight millions of coins more accurately than any human or coin-counting machine. Arcades often use a scale to measure the mass of your game tickets as a way to count your tickets. In chemistry, we count atoms and molecules by weighing, since the minute size and immense numbers make counting by hand impossible. The equation for counting by weighing is you start by knowing the mass of the entire sample. You divide that by the average mass of an individual piece. And if we consider units for that, the mass of your entire sample would be measured in grams. That's going to be divided by the average mass of your individual piece, which will have the units of grams per piece. So if you divide grams by grams per piece, the grams will cancel and you'll be left with number of pieces. So that's how it works. The mass of the entire sample divided by the average mass of an individual piece will give you the number of pieces. Turning our discussion here to just some vocabulary discussion, oftentimes in the next couple of units you're going to be hearing the term particle being thrown around. Particle is sort of a generic umbrella term, and it can represent several specific types of particles, but really generically it's referring to the smallest unit of a substance, and we're going to be using it to describe one of three types of particles. Either an atom, a molecule, or a formula unit. So let's take a look at those three types of particles and identify when you will use those three terms. An atom is the smallest particle of an element, and you'll be able to recognize it because you will see elemental symbols. So when you see an elemental symbol, you know that the particles you're referring to are atoms of that element. A molecule is defined as a neutral group of atoms joined together by covalent bonds. You'll be able to recognize a molecule when you see the formulas H2O, CO2. These are examples of molecules. How do we know? First of all, it's more than one atom connected together. And but the telling thing is that the elements in this molecule are nonmetals. Remember, nonmetals bonded together by covalent bonds make molecules. So if you're looking at the formula, look for all nonmetals, and you'll call those units, you'll call those particles molecules. A formula unit is the lowest whole number ratio of ions in an ionic compound. Well, how will you recognize an ionic compound? That's right, you'll be looking for a combination of metal and nonmetals in the chemical formula. So you don't refer to MgCl2 as a molecule, you refer to it as a formula unit because it's a ratio. It's not a free-floating unit like H2O is a free-floating group of atoms distinct from all the other H2O molecules. Formula units are just a grid. Think back to the model of the sodium chloride that we had in the classroom. So atoms, molecules, and formula units. All right, let's take a look at a sorting activity. See if you can discover or predict these various formulas down here and whether they can be described as an atom, a molecule, or a formula unit. If I were to ask you what kind of particle they are. So let's start this out here. If I look at Fe, if I bring that up, Fe just with a elemental symbol, it's an atom. So here I see another elemental symbol, so that's an atom. I don't see any others down here that are elemental symbols yet. There might be some buried underneath, but let's take a look. H2O, H2O, H and O are nonmetals, so that's a molecule. NaCl, metal, nonmetal, it's an ionic compound, so we refer to that particle as a formula unit. CH4, carbon and hydrogen are both nonmetals, it's a molecule. C6H8O7, carbon, hydrogen, oxygen, all nonmetals, making it a molecule. CaCl2, metal, nonmetal. Calcium's a metal, chlorine's a nonmetal. That makes it ionic, and we refer to those particles as formula units. HCl, H is a nonmetal, Cl is a nonmetal, it is a molecule. C6H14, carbon and hydrogen, both nonmetals, it's a molecule. O2, this is an interesting one because it is an element, but there are two atoms of the element bonded together. They're both nonmetals, so we have to classify that as a molecule even though it's an element. So kind of it bridges the two categories, but it's not a single atom, so you can't call it an atom. Ki, K is a metal, I nonmetal, making it ionic. Therefore, a formula unit. Helium, there's a single elemental symbol, so its particles are called atoms. C10H8, carbon and hydrogen, both nonmetals, we call those particles molecules. MgSO4, metal, nonmetals, it's a formula unit because it's ionic. And Cl2, here we have an element of chlorine, but there are two atoms bonded together making it a molecule, and so there you have it. A little practice in discovering how you refer to these different compounds and elements as either atoms, molecules, or formula units. This is a review from the last unit. There are 7 elements that exist diatomically in nature. You can either remember it by Hofbrinkel: hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. These are the 7 elements. Here they're highlighted as a 7. If you also can't forget about hydrogen over here. They are elements, but their representative particle is a molecule because they are diatomic. This concludes our video lecture from Chapter 10, Section 1. There is another lecture to follow, which will also be from Section 1 of Chapter 10, and we'll get into more details about a mole in chemistry. See you in the classroom.